This lesson is on Module 4.3 and Zeros of Polynomials. We're going to take what we learned in 4.2 with our long division and synthetic division, and we're going to be able to find all of the zeros of the function that's given to us. So when I have f of x is equal to x cubed minus 3x squared minus 16x minus 12, I'm going to be able to find the three zeros that are in this polynomial here. If I have a fourth degree polynomial like I do on number 2, that means that I am looking for 4 zeros. So the degree of our polynomial tells us the number of zeros that our answer should be. So it says that we are given that f of k is equal to 0, and that is a factor, and then we're going to solve completely. So this is a factor. Another way that you have seen this is before in the last section, it would have been x cubed minus 3x squared minus 16x minus 12 is being divided by x minus 6. So we've already solved that linear factor for what it is, and this 6 is going to go in our box for the synthetic division. So we have 6. We're going to take our coefficients again. We have a 1, a negative 3, our negative 16, our negative 12, and we're going to do synthetic division. And so because this is already a factor, my remainder should be 0. So I'm going to bring down the 1, I'm going to multiply, I'm going to add straight down, I'm going to multiply, add straight down, I'm going to multiply, add straight down. So my remainder is 0, which means that x was a factor. Okay, I'm going to rewrite that as x minus 6. And then my new polynomial, my answer here, remember we drop it by 1. So this 1 is an x squared. The 3 is 3x. The 2 is my constant function. Okay, we're going to set this equal to 0 because we are trying to find the zeros of the polynomial. I already know that one of them is x minus 6 equals 0. So I can solve that one. We already know that it's 6. It matches up with what we divided by originally. For the second part, we have x squared plus 3x plus 2. I need to still factor that. So that is going to factor into x plus 2 and x plus 1. Both of those are still equal to 0. So each piece is equal to 0. And we have x is equal to negative 2 and x is equal to negative 1. I have the 6 that I divided by originally. The other two zeros are x minus 2 and x minus 1. Okay, so if I multiply out x minus 6, x plus 2, and x plus 1, it'll take me back to the original function that we started with. Okay, but my answers to the problem are x equals 6, x equals negative 2, and x equals negative 1. On problem number 2, again, I said it was an x to the 4th. It means that we're looking for 4 zeros. It tells me that I have a double root at k equals negative 1. That means that I need to do synthetic division twice with the same value. So I have two answers like we had over here, two answers. They're just both negative 1. So again, I'm going to do synthetic division twice with a negative 1. So I have negative 1, and our coefficients are 1, 3, negative 3, negative 11, and negative 6. Bring down my 1, multiply. Multiply again, I get negative 2, gives me negative 5. Multiply again, that gives me positive 5, which gives me a negative 6, which gives me positive 6, which gives me a 0. So I know that negative 1 is a factor of the polynomial, but because it says a double root, it means that there is a second negative 1 in there. So again, our polynomial started out as this is our 4th degree polynomial. The answer is a 3rd degree polynomial, but I need to do synthetic division with this new polynomial here again with k equals negative 1. So I'm going to put another box to do the synthetic division again. Draw my line. I bring down the 1. I multiply. Add straight down. Multiply. Add straight down. Multiply. Add straight down. So this new answer is my x squared answer. Okay. So these coefficients now, it starts with x squared, x, and our constant function. The two factors out in front here, we're going to rewrite them. We have x plus 1 was a factor, x plus 1 was another factor, and now we have x squared plus x minus 6 equals 0. I could set each of these pieces equal to 0 already. I am going to finish factoring first, and then I'll do all 4 of my answers. So I'm going to copy this down. We have x plus 1, x plus 1. And this time when I factor, I'm looking for the two numbers that multiply together to give me negative 6 that are going to add to give me a 1. So I have x plus 3 and x minus 2 equals 0. So now I have my 4 factors. Those are my 4 answers when I set each piece equal to 0. So we have x plus 1 equals 0, x plus 1 equals 0, x plus 3 equals 0, and x minus 2 equals 0. Solve each of those. We get x equals negative 1, x equals negative 1, x equals negative 3, and x equals 2. And those are my 4 answers. Okay, so when it says double root, it means that you're doing synthetic division twice with each of those values. Okay. On number 3, we have f of x is equal to x cubed minus 4x squared and minus 4x plus 16. The 0 that we have is at 4. That 4 goes in the box. Again, I'm going to be looking for 3 zeros. Our coefficients are 1, negative 4, and 16. Bring down that first starting point, multiply, add straight down, multiply, add straight down, multiply, add straight down. So again, I started with a cubed function. My answer here is a square function. So our first factor was x minus 4. And then our answer here, we have x squared. I don't have an x term, but I still have my constant of negative 4 equals 0. And now we factor. The x squared minus 4 is a difference of squares. I have x minus 4, and then x plus 2 and x minus 2 equals 0. Now I take each of those pieces and set them equal to 0. So I have x minus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So we're going to end up with x equals 4, x equals negative 2, and x equals positive 2. There's our 3 answers for our cubic polynomial. Okay. On number 4, we have x cubed minus 4x squared minus 7x minus 2, and the 0 that we're given is 2. Our 2 goes into the box. We have 4, a negative 4, a negative 7, and a negative 2. We're going to bring that first one straight down. We go back and multiply. We add straight down. We go back and multiply. We add straight down. We go back and multiply. And then we add. So again, the 2 is a 0 of the polynomial. Came out with a remainder of 0. This is my new function that we're working with that we're going to have to factor. So we have x minus 2 is the factor that we started with. And now we have 4x squared plus 4x plus 1 equals 0. Because again, the whole goal today is to find the zeros of the polynomial. So I still need to factor the 4x squared plus 4x plus 1. It's a perfect square trinomial, so we're going to have 2x plus 1 and a second one of those. And then we're going to set each of those pieces equal to 0. So I have x minus 2 equals 0, 2x plus 1 equals 0, 2x plus 1 equals 0. When I solve, I get x equals 2, x equals negative 1/2, and the second x equals negative 1/2. So you'll notice that we have the same answer again. I could have told you that f of x is equal to the 4x cubed minus 4x squared minus 7x minus 2, and that it had a double root of negative 1/2. Just like in number 2, we had the double root of negative 1. So we do have three answers. We have x equals 2, x equals negative 1/2, and x equals negative 1/2. The second part of the lesson, when you turn the page to page 9, says that we're going to write the polynomial function with least degree that has real coefficients and the given zeros. So on this one, I am starting with zeros. I have x equals 2 and I have x equals 5. I'm going to rewrite that so that we can see that we have two separate ones. We have x equals 2 and x equals negative 5. And we're going to do the reverse steps that we have been doing when we've been doing all of the work for solving. Okay, so we're trying to get back to the polynomial that this really is. So you're going to turn this x equals 2 and x equals negative 5 into factors, which means that you're going to move it over to the other side. I have x minus 2 equals 0. I'm going to add the 5 over to the other side. That equals 0. So those are my two factors now. So we have a function f of x is equal to x minus 2 times x plus 5. This is where you're normally used to going, and we set each piece equal to 0 and then we solve it. We are doing the reverse order when we are writing the equation of the polynomial. The last step of this is to actually multiply this out. So we really have the function x squared plus, I'm going to have a 5x and a minus 2x to get 3x, and then a minus 10. So my actual polynomial is f of x is equal to x squared plus 3x minus 10. Okay, so we're used to starting here, factoring it, setting each piece equal to 0, and then solving for x. We're just doing the steps backwards because we're trying to find out what that polynomial is. So on number 2 here, it says that we have x is equal to plus or minus 3. Again, that is two answers. We have x equals 3 and we have x equals negative 3. We're going to write them as factors. I have x minus 3 equals 0 and x plus 3 equals 0. And now I multiply the factors together to get to my polynomial. So we have f of x is equal to x minus 3 and x plus 3. Multiply that out. It's a difference of squares. I get x squared. I get a minus 3x and a positive 3x. Those make 0. And then I have the 3 and the negative 3, which gives me negative 9. So we have f of x is equal to negative x, f of x is equal to x squared minus 9. Okay, so again, we're used to doing it the other way. Okay, but in this case, we're trying to write the equation of the polynomial. On number 3 here, we have x is equal to plus or minus the square root of 7. Okay, there's a couple of different ways to solve these. We are just trying to get back to the original polynomial, so you could undo the work that we did from completing the square. To get rid of the square root, we square both sides. So I have x squared is equal to, and when you square a positive, you get positive. When you square a negative, you get a positive. And so the square root of 7 squared, that just gives you 7. And I'm going to subtract that over to the other side, and I'm done. That is my polynomial. Okay, so I have f of x is equal to x squared minus 7. The other way to do it is to say that you have x is equal to the square root of 7 and x is equal to the negative square root of 7. Move it over. You have x minus the square root of 7 equals 0. X plus the square root of 7 equals 0. And then you have factors. You have f of x is equal to x minus the square root of 7 times x plus the square root of 7. That's a difference of squares as well. Okay, so when I multiply it out, I have x squared. I'm going to have a positive x root 7, a negative x root 7, which gives you a 0. And then when I multiply the negative square root of 7 and the positive square root of 7, I get negative 7. Okay, so either way works. Pick your favorite, stick with it. Get good at one of the methods. Okay, so if you see square roots, you can try squaring it. That'll work. Or you can still create the factors and then multiply it out. On number 4 here, we have x is equal to 3. We have x is equal to a positive 3/2, and x is equal to a negative 3/2. And we need to get each of these, we need to get them to 0. So I have x minus 3 equals 0. It's 2 steps to getting this one so that we have our 0. So I'm going to multiply by 2 first. So I get 2x is equal to 3. Same thing over here. I'm going to have 2x is equal to negative 3. And now I'm going to move the 3's over. So I am doing a 2-step equation there. So this one says now that we have 2x minus 3 equals 0 and 2x plus 3 equals 0. I'm going to take my 3 factors. So my polynomial when I'm done should be a cubed function because I have 3 zeros. I have 1 and then 2 for the positive and 3 for the negative. So we're going to multiply those together. F of x is equal to x minus 3, 2x minus 3, and 2x plus 3. When I go to multiply this out, I'm going to multiply it in ways that benefit me. When I'm looking at these back two, those are a difference of squares again. So I'm going to multiply them first. I'm going to have x minus 3, and then when I multiply these difference of squares, I get 4x squared minus 9. Okay, take a minute to double check that for yourself. The final step is to multiply these two together. I'm going to end up with 4x cubed minus 12x squared minus 9x plus 27. So when I multiplied that out, I took the 4x and squared and I multiplied it times the x and times the negative 3. And then I took the 9 and multiplied it times the x and the negative 3 so that my answer was already in descending order. But we had 3 zeros and now our function is a cubed polynomial. Okay, so we have 4 more. These are just lots of practice with this stuff. On number 5, you have x is equal to negative 3, x is equal to negative 2, x is equal to 4. I'm going to move them over so that I can get my factors. I have x plus 3 equals 0, x plus 2 equals 0, x minus 4 equals 0. And now we're going to multiply them together. So f of x is equal to 1 factor of x plus 3, 1 factor of x plus 2, 1 factor of x minus 4. On this one, it doesn't matter which ones you start with to multiply them out, whether you do the front two or the back two, you just need to start multiplying. If I multiply out the front two, it's going to be x squared plus 5x plus 6, and that needs to then be multiplied by x minus 4. And so when I multiply that out, I am going to start back here with the binomial and distribute the x to all 3 terms, and then I'll distribute the negative 4 to all 3 terms. So we have x cubed plus 5x squared plus 6x, and now I'm going to do the negative 4. So I have negative 4x squared minus 20x minus 24. So we get x cubed plus x squared minus 14x minus 24. And there's our polynomial. On number 6, it's very similar to number 3 since we have a square root of 5 in there. You can write it as one of your factors is x is equal to 2 plus the square root of 5, and the other one is x is equal to x minus 2 minus the square root of 5. The way that I like to do these ones is I like to move my terms. It's the opposite of, again, completing the square. So I'm going to subtract the 2, and that leaves me with the square root of 5. To get rid of the square root of 5, I'm going to square both sides of the equation. I need to multiply this part out, this x minus 2 squared. That's going to give me x squared minus 4x plus 4. Again, that's x minus 2 times x minus 2. On this side, when you square the positives and the negatives, you come out all positive there. The square root of 5 squared just leaves you with 5. And then I'm going to subtract 5 over to the other side. So my function is x squared minus 4x minus 1. Should also take a minute to note that when you're dealing with square roots, they always come in pairs. So if we had just listed 2 plus the square root of 5, you would have to know that 2 minus the square root of 5 is there. And those are called conjugates. So on number 7, I see that I have x is equal to 2 minus 5i. So we're coming back to our complex numbers. Complex numbers and radicals always come in pairs. So if I have this answer, I also have 2 plus 5i as another answer. So I'm going to rewrite this so that it matches what I had for number 6. I'm going to say that we have x is equal to 2 plus or minus 5i. And like I did, I'm going to take that real part of the 2 and I'm going to subtract that from both sides. Leaves plus or minus 5i on this side. To get rid of I, we're going to square it. Square this side, we're going to square this side. Again, when I multiply this out, I get the same answer I did in the last one. So I have x squared minus 4x plus 4 again. When I multiply out this side, I get 25i squared. But we know that I squared is equal to negative 1. So I, remember, is the square root of negative 1. I squared, when you square both sides, you just get negative 1. So I squared is equal to negative 1. So we'll rewrite this. That gives me a negative 25 now that I'm going to add to the other side. So my polynomial function, f of x, is equal to x squared minus 4x plus 29. On number 8, we have that x is equal to 2 and the square root of 6. Again, with the square roots, they come in pairs, and so I have the positive one already. I need to write in my other one of negative square root of 6. And I'm going to rewrite it like I did on those other ones. The difference here is that we have x equals 2, that's 1, 0. And then we have x equals plus or minus the square root of 6. So those ones are separate. You got to see that there's a comma in between the 2 and the square root of 6 versus having a minus sign here in the middle. So those are connected. It is 2 plus or minus 5i. There is a difference there. This one is just a comma. Those are separate zeros. So on this one, I have x minus 2 equals 0. Over here, when I'm going to work on it, I'm going to square both sides. And I have x squared is equal to 6. And then I'm going to subtract 6 from both sides to get my other 0. So I have x minus 2 and x squared minus 6 are my two factors. So we have f of x is equal to x minus 2 times x squared minus 6. And again, I need to multiply that out. So we have f of x is equal to x cubed minus 2x squared minus 6x plus 12. And that's my final answer.